So in the last video I have discussed about C++ STL till map containers, and here in this video I'm gonna discuss about other containers such as stacks, queues, etc. and algorithm as well. So if you haven't watched the previous part of this video, I would highly recommend go and watch that video in order to have a better understanding of the concept. So without further delay, let's get started. So let's talk about pairs. Pairs are used to combine two values that may be of different data types. So advantage of using pair is we can return multiple values from the function. Like it is a one way of doing, I mean returning multiple values from the function. We could use vectors, array as well, but it is one of the way to return multiple values from the function. So let's talk about the definition part of the pairs. So pairs are defined as, firstly we'll write the pair, which is the name of the STL container, and then inside the angular bracket we just insert the data type, first data type and the second data type, and then we write the pair name. Let's see in the VS Code how it works. So I'm uncommenting this line number 5, and so it is the definition of the basic definition of the pair. So pair is written and inside the angular bracket int comma int, which are the data types of the first value and the second value, and p1 is the name of the pair. So how we insert a value into the pair? So one of the ways to insert using the curly braces, like I'm defining a pair as well as assigning a value to it. So the pair is of type int comma string. So one value is string and another is, I mean one value is string and another is int. So it is written 1 for int and vaba is string. So p2 is a name of the pair. Now let's talk about the methods used in pair. Methods are commonly used methods are make pair. So let's talk about that. I'm going to uncomment this line, and so we can print the pairs like p2 dot first for printing the first value of the pair and p2 dot second for printing the second value of the pair. Like if I print p2 dot first and p2 dot second here, it should return 1 and the above. Let's check it out. So see, it is returning 1 and the above. Now I'm making pair using the make pair function. So first value is, I have passed 2 and second value is 1. So let's see if the pair is made or not. Like we made pair p1 using the make pair function. So for that purpose I'm going to uncomment this line number 12 to check if the pair is made or not. But before that I'm going to comment this line number 8 so that previous 1 comma above is not printed. So I'm going to run this. You see 2 and 1 are printed, means the pair is inserted successfully. So now I'm going to discuss about the swap function. For that purpose I'm going to make another pair which is p3, and I'm going to swap the p3 with the p2 pair is this, and I'm going to take it down, and let's see, we are going to swap the p2 pair and p3 pair. So for swapping I'm going to uncomment this, and before swapping I'm going to print these two pairs. So before swapping it is 1 vaba for p2, 1 and vaba, and for p3 2 and pair, as you can see 2 and after if I swap this using the swap function which is shown here, if I swap this I have to take this up and uncomment it. So if I swap using the swap function, the p2 value will be given to p3 and p3 will be given to p2. So let's check. I'm going to run this code and let's see what happens. So yeah, you can see here Like before swapping it was one web of two pair, and after swapping the P2 becomes two pair and P3 becomes one web of. So swapping is performed. Now access we have already seen, like how to access. We access is using the p2 pair is there, so we access using the keyword first and second. First for the first getting the first element, and p2 second for getting the second elements. Like that we access element in pairs. So this is it for pairs, and now we are moving to queue container. So queue container is a container which follow FIFO order, first in first out, and element are inserted from back and deleted from front. Okay, so for firstly we will see how we define a queue. So let's move to the VS Code in order to better understand the things. So I'm uncommenting this line number 5. So here the basic definition of the queue is given. The name of the queue STL container, and then inside the angular bracket int is written, which is a data type, and name of the queue, which is queue. And I'm going to insert few element to check the functions which are present over here, like empty function. So for the method empty, let's check. I have inserted value 1, 2 and 3. So let's check if the queue is empty or not. So empty function returns value 0 or 1, and if the queue is empty, then it will return 1, else it will return 0. So for our case it should return 0 because our queue already have some values present over here. So let's run this. Yeah, it is returning 0. It means queue is not empty. So if I comment it out, then you see it will return 1. Yeah, it is returning 1, means the queue is empty because we have commented these values. Now again we are uncommenting this, and I'm commenting this, and let's see the other function, which is the size function. Size function, we already know that it is used to return the size of the queue or a container. So if I do this, it will return 3 because the size of container is 3. Yeah, it is returning 3, you can see here over here. And both these functions take, like all the functions take over one time complexity. So we are going to discuss each function one by one. So we have already discussed empty and size function. Now it's turn for front function. So for front function and back function, I'm going to uncomment this line number 16. So front function shows the front element of the queue, and back function shows the back element of the queue, the last element of the queue. So when we inserted 1, 2 and 3, then it goes like 1 is inserted, then 2 is inserted at the back of 1, and then 3 is inserted. So front will show the front element of the queue, and back will show 3, which is the last element of the queue. So let's check it out. Wait, let me just check where is the error. No error is there. So 1 and 3 are printed. Like 1 is representing the front function front element, and 3 is the last element, which is the back. So it is returned by the front function and it is returned by the back function. So we are done with front and back function. Now let's move to the push function. Push function we have already discussed. Like here we are using push function to push the element into the queue. So it is inserted from the back, and these all function takes O of one time complexity, including the pop as well. We are going to discuss the pop function. So pop function basically used to pop or remove element from the queue. So let's check it out. If you want to remove the element from the queue, use pop function. So I'm going to pop the element 1 from the queue. So let's check it out. So it should remove the 1 from the queue because we are doing q dot pop. So it will delete the element from the front. First element will be deleted from the queue. So let's see. Wait. I have written wrong thing. I have to print the q dot top after doing, I mean q dot front, after doing the pop. So front function will return the front element, which will be the 2, because we have already popped the 1 element. So let's see, it is returning 2 or not. Yeah, it is returning 2, as you can see. So it is just because we have used the pop function, so it wipes out the element 1 and it returns 2. From the front function it is returned. So now I'm going to just remove it because we want the element 1. So this is the basic code to print the whole queue. So q dot empty returns, if the queue is empty or not. So if the queue is not empty, then this while loop will run. And as we can see, the our queue is not empty as 1 2 3 are already present. So q dot front will print the element one by one. So it will firstly print 1, then it will pop it out, then 2, then it will pop it out, then 3, then it will pop it out. So it will, let's print it. So you can see 1 2 3 are printed. So this is it for q. So let's discuss about deq. So deq is a doubly ended queue in which the deletion and insertion from both the side is possible. Like in the queue, you can see that deletion is done from the front and insertion is done from the back. But in this, the deletion and insertion can be done from both the ends. So let's check the definition of the queue. DEQ, I mean. So DEQ, in DEQ, we define like just like a normal queue. So let's see in the VS Code. I'm going to uncomment this line number 5. So it is a basic definition of DEQ. Like DEQ is written, then inside the angular bracket int, which is the data type of the DEQ, and then the name of the data type. Like in our case, it is DEQ. So I'm going to insert few elements just like we did in Q 1 2 3, and for that I'm going to print the front and the back element like we did in the Q part. So let's see if it is working or not. So yeah, 1 3 are printed just like we did in Q. So now let's discuss other functions of the DEQ. Like in DEQ, we can insert and delete from the both the ends. So we have more functions than normal queue. So we have 4 functions actually: pop front, pop back, push front, push back. Like pop functions, pop front and pop back are for deleting the elements from front and back, and push back and push front function are for pushing or inserting the element from front. So let's discuss each method one by one. So I'm going to uncomment this pop front function in order to understand, and we are going to print all the elements using the while loop. So in the while loop, you can see deq.empty is also there. Empty function we already know. Empty function is used to return whether the deq is empty or not. So if the deq is empty, then it will return 1, else it will return a 0. So in our case it is not empty, so it will return 0. So so it will run, the while loop will run only when the deq is not empty. So in our case it is not empty, so it should return deq dot front, which will be 1, and then it will do a pop front. So let me write this so that we can understand easily. 1 2 and 3. So deq is not empty, and then deq front will be this one. This one will be printed, then pop front means 1 will be removed from here. Then again the loop will run, and then deque is not empty, then 2 will be printed, then it will be pop, and then again 3 is mm 3 is printed, then it will be popped out from the queue, and it will the output will be like 1, 2 and 3. It will be in ascending order. Let's run this. Yeah, you can see 2 3 are there because we have deleted one element. Deque dot pop front, one element is deleted. If I remove this, if I comment this, then it should return whole deque elements. Let's run this again. You can see 1 2 3 are printed, so this is printing the whole deque and in the ascending order. If you want to print the elements of the deque in descending order, then we can do by using like printing the back elements and then popping also the back elements. So for that purpose I am going to uncomment this line of code. So I'm going to again comment these things so that our queue does not becomes empty, because we are performing the pop operation each time. So our queue will become empty like we have discussed here. So I'm going to copy this and 1 2 3 and paste it over here in order to understand in a better way. So firstly, the queue was not deque was not empty, so deque back was printed. So deque back was printed, and then deque back was pop back, means it is removed from the deque. Then again 2 is printed and 2 is pop back from the back, and 1 is printed, then 1 is also pop back from the end, and like this it will be printed. So let's print it. 3 to 1, yeah, it is showing 3 to 1. It is because it is popping element from the back and also printing the elements from the back, so it is printed in reverse order 3 to 1. So this is it for the deques. Now let's discuss about the priority queues. So priority queue is an implementation of a heap data structure. Like in this, we can make a min heap or a max heap. So by default, it is a max heap. Like the first element in a priority queue is always greater. So if I talk about the definition of the priority queue, so it is like priority queue. If I uncomment this line number 6 from the, so you can see priority queue, then the angular bracket, and inside it the data type of the priority queue, and then the name of the priority queue. So it is, we are doing for the max heap, means the first element of the priority queue will be greater. So this is the basic definition of the priority queue. If we want to make a max min heap, then we can use the this definition: priority queue int and vector int and greater int, and then angular bracket closed, and then pq dot to, which is the name of the priority queue, and the data type of the priority queue is int type. So this will make a min heap for our queue. So in this, the first element of the priority queue will be minimum among all the elements. So let's talk about the methods in priority queue. So methods are empty methods. So empty, size, top, push, these four are basic methods of priority queue. So if I talk about the empty method, we already seen in every other containers, like it is used to print whether the priority queue or a container is empty or not. If it is a empty, then it should return a 1, else it should return a 0. So in our case it is empty because we haven't given any values, so let's print it. It should return 1. Yeah, it is returning 1, you can see. Now if we add the values to the priority queue and move this down, so it should return 0. Yeah, you can see it is 0 because now our priority queue has some values like 1 5 2 6. Okay, so I'm again commenting this, and let's see the other method, which is a size method. Size method we already know, it is used to print the size of the container. So in our case the size will be 4 because we have 4 elements inserted over here. So let's print it to check. So you can see 4 is printed, which is the size of our priority queue. Now if I see the top and push function, so we will see these function. We have already seen the push function, which is used to push the element into the priority queue, and it takes log n time. Means we, if we are pushing 4 elements, so it takes 4 log n time, means 4 log 4 times. So for each time we are pushing element, it takes 4 log n times. So we are pushing 4 element, so it will takes 4 times log n time. So if I talk about top function, so top function is used to display the top element of the priority queue. So I'm going to show how it will work by uncommenting this loop. It is a loop, while loop. It will print the elements of the priority queue if it is not empty. The priority, if it is not empty, then it will print all the elements. So priority pq dot top will print the top elements of the queue. So in this, in the priority queue, the first element is, I have already told that first element will be greater among all the elements in the max heap. So it will be like 6, then 5, then 2, then 1, because first element will always be greater. So I can also write as 1 and 5 and 2, because only first element is greater. We have not talked about other elements. So first element will be greater, so 6 will be printed for the first time, then it will be popped out from the priority queue. Then again the pq dot top will have the maximum element, which is 5. So 5 will be printed, and then it is popped out from the d from the priority queue. And then again pq dot top will print 2 and pop it out from the priority queue. And then the last element 1, which is printed, and then again it is also popped out from the priority queue. So if I run this code, it should return me the output which I have shown here, like 5, 6, 5, 2 and 1. Let's see. Yeah, it is returning 6, 5, 2, 1, and here also I have written 6, 5, 2, 1. So it is returning the output as we have expected. So I'm going to again comment this, and we are going to see the min heap, how it works. So you can see for min heap we have defined here, and we named it as pq2. So we will be using pq2. So I'm going to uncomment this to insert a values in pq2 priority queue. We are inserting one same values like we did in normal max heap priority queue. So I'm going to print all the elements of priority queue min heap. So in our case, in this case, the min heap is there. So elements will be like, the first element will be the minimum element. So it will be like 1, then 5, then 2, then 6. So firstly 1 will be printed because pq2 is not empty. So pq2 top will be the first element. So 1 will be printed. So output will be like 1, then it is popped out from the priority queue or min heap, and then the minimum element is 2, then 2 will be printed and popped out from the priority queue, and again then 5 is printed and popped out from the priority queue, and at the last the 6 is printed and popped out from the priority queue. So output will be 1, 2, 5, 6. Let's check this out. Yeah, 1, 2, 5, 6 is the output of min heap. So this is it for priority queues. Now we are going to discuss about stacks in STL containers. So stacks is basically a container which follow a LIFO order, which means last in first out. So element which is inserted at last will be taken out first. So let's see methods, stack methods, as well as the definition of the stacks in the VS Code. So definition of a stack is simple, just like a vector or a queue. So we are uncommenting this line number 6. So it is basically the stack, which is a name of the STL container, then inside the angular bracket int the name of the data type and the stack name of the stack, which is ST over here. So methods are empty, size, top, push, pop. So we are going to discuss each method one by one. So empty method, we already know it is used to print whether the stack or container is empty or not. So in our case it is right now empty, so it should return 1. Yeah, it is returning 1. I'm again commenting this, and if we push some elements over here, and then again if I write this, it should return 0 because the stack is not empty, because we have added 1 2 3 elements in the stack. So let's discuss another method, which is size. Size is used to print the size of the stack, as we have seen already. So it should return 3. Yeah, it is returning 3, which is the size of the container stack. Now I'm going to see the top and push pop function. So we will see these functions simultaneously. Push function we have already seen, like in the here we are using that to insert an element into the stack, and top and pop function we will see simultaneously using this while loop. So in the while loop it will run only if the stack is not empty. So in our case it is not empty, so it will run. So it will firstly print top element, like stack uh, top element will be the element are inserted like 1 then 2 then 3. So it will be like firstly 1 will be inserted, then 2, then 3. So top element is 3. So firstly 3 will be printed, then 2 will be printed, then 1 will be printed. So here the same thing is going on. Like loop will run, stack top 3 will be printed, then it will be popped out, then again 2, the top will become 2, 2 will be printed, then it will be popped out, then 1 will be printed. So the final answer should be 3 2 1. So let's check if it is giving the same answer or not. So yeah, it is giving the same answer, 3 2 1. So like these we perform operations in stack. So this is it for the stack. So now let's see the algorithms in STL library. So firstly we will see the sorting algorithm, and then we will see the reverse method. So sort method is basically used to sort a vector or an array. It takes n log n time complexity to sort a vector or an array. So it is the fastest among all the sorting algorithms, because it is a mixture of more than one algorithms. So it is the fastest, that's why. So let's see the definition and its working in the VS Code. So I'm going to uncomment this line 11 and 12 to see how it works. So in the 11 line, the vector is defined with the values provided to it, and in the 12 also the integer array is defined. We are going to perform the sorting operation on both vector as well as array. That's why I have defined these two over here. So let's see how it works. So I'm going to uncomment this code section to print the array before and after sorting. So before sorting we will be printing the v, which is this array. Before sorting it will be 3 1 2 0 and 5, and v2 also 3 1 2 0 5, the same content is there. So we will be printing before sorting, and after sorting we will be printing. So let's see. So yeah, you can see before sorting it was 31205 and v2 was 31205, and after sorting it becomes 01235, means it is sorted. So sort function basically sort these two vector and an array. So we can also perform partial sorting as well. Like if we want to perform partial sorting, we can do like, so if we want to sort from 1th index to the 3rd index, we will write 1 over here and plus 3 over here. And similarly for array, we will write 1 and plus 3 over here. So it will sort elements from, uh, it will sort among these elements 1 to 0. Like it will be like 0 3 0 and 1 and 2, like this. Only this part of the array will be sorted. Similarly for this also, this part of the array will be sorted, means from the 1th index 0 and the 1 is 1th index is this and 3rd index is this. So from the 1th index to the 3rd index, it will, the sub array, this sub array will be sorted only. So let's try it out. So as you can see, before sorting it was 31205, and after sorting it becomes 30125, means it only this part of the array is sorted. 0 come here and then 1 then 2. Only this one from the 1th index to the 3rd index is sorted. So this is how sorting works. So now let's discuss the custom sorting using comparators. So for that I'm going to comment this out and uncommenting the vector v3, and we are going to sort this v3 vector using the sort methods and using the comparator. And you can see that it is showing error because we haven't defined the comparator yet. So I'm going to define the comparator over here. So the comparator function, now the error is gone because we have defined the comparator function. So what it does, it takes the element from the vector v3 and it will sort according to this condition. Like it will see which element is greater and it will return the greater element. So let's suppose 3 and 1 is passed as a and b, so it should return 3 first. Like that, it will goes on. Like for 1 and 2 it will give 2, and for others also it will return a greater elements. So this is how a comparator works. Comparators are not just limited to sorting a vector or an array in a descending order, but we can also add custom condition to the comparator to sort the array or a vector in a way we want. So this is it for the comparators. So now let's see how reverse function works in STL. So we'll see in VS Code how it works. So here we have taken v3 vector and we are going to perform reverse operation on v3 vector. So for that we are performing from v3 dot begin to the end. From beginning to the end we are performing this reverse operation. So what it does, it will reverse the vector, means the 3 will be swapped with 5 and 1 will be swapped with 0 and 2 will be swapped with 2, means it will be like 5 and 0, then 2, then 1, then again 3. So the output will be like this after reversing it. So let's see how it after printing this. Okay, so Yeah, you can see 50213 means if I lower this terminal, so you can see the elements were 31205. So 3 was swapped with 5, 1 was swapped with 0 and 2 with 2. So 50213. So this is how reverse function works in STL. So now let's discuss about the sort in pairs. How we perform sort on pairs. So for that I'm going to comment it again and uncomment this pair part. So here we have defined one pair of size 4 and we are inserted elements into it. For 0th, for first element we have inserted 3, 1. First pair we have inserted 3, 1. Second pair 2, 3. Third pair 3, 0 and 1, 0. So we are going to perform a sort operation on this. So it will goes like, it will first check the first element and find the smallest one. So here this is the smallest one. So 1, 0 will be printed. 1, 0 will be printed means the first pair will be printed. First pair will be printed and after that it will check the minimum among these threes. So 3, 2 and 3. So minimum is 2. So second pair will be printed 2, 3 and then there is a tie means 3 is equivalent to 3. Then in that case it will check the second element. So second element here, in case of first element it is 1 and in case of third element it is 0. So it wins. So this will come first 3, 0 and then 3, 1. So here you are observing a thing like 3, the first element is compared and if there is a tie then it will be the comparison is done on the basis of the second element. Like in this case the 0th case and the second case, the first element 3 and 3 were equal, so that it was a tie, so the decision is made on the basis of the second element. So second was 0 for the second element and for 0th it was first, so it came first and it came last. So this is why the order will be 1, 0, 2, 3, 3, 0 and 3, 0. I mean 3, 1. So let's print it. Yeah, you can see order is same 1, 0, 2, 3, 3, 0, 3, 1. So this is all about the C++ STL and there was some containers and algorithms I skipped because they were not very commonly used. Like there was some multi-maps, multi-sets and unordered map, unordered set. So basically advantage of unordered map is and unordered sets are like they uses constant time complexity for in average case, whereas map and sets uses log and time complexity. So this is the basic advantage, you can read about it. So thank you for watching my video and the link of the notes as well as the code is provided in the description. You can go and download it, and if you find this video helpful then please vote this up and subscribe to my channel.